and then one more digit until you get the final answer. Otherwise, if we have several steps and each step use this for the next step, then run up or run off will cause the extra error. Its purpose is to avoid accumulation, accumulating should be accumulating error. If you run up or run off. Because if you're going to use this to next step, if you run up or run off, then second step is run up or run off after several steps. It's a big error. So this X bar everybody can understand. Next is about how to calculate the standard deviation S. S, we introduced this formula, and now how to show you how to actually calculate. The formula is, you remember the formula is sigma xi minus x bar squared over m minus 1 or root, right? This is the formula. Then how can we use this formula? So xi is each individual number. So each individual number we have 4. So 821 minus x bar is the average. Average is 823.3. The first letter. This sigma means add them together. So we need to use the second. Second 834 minus average 823.3 square again. The third one 783 minus 823.3 squared. Last one is 855 minus 823.3 squared. So this represents the sigma xi minus x bar squared. Okay. Sigma is total, right? Over n minus 1. N, we have 4 numbers, means n is 4. Right, 4 number. 1, 2, 3, 4. 4 number. So n is 4. 4 minus 1. Then square root. Most of your calculator can do this, and Excel also can do this. This 30.3. Then relative standard deviation equals to S over X bar times 100%. S, we just get it. S is 30.3. X bar, we just get it. 823.3. Which is 3.68%. Okay. So now, do you understand how to use this formula calculate S? Okay, just this example. This is section 1. Section 2 about the comparison of standard deviation with the F-test. So F test tell us if two standard deviations are significantly different from each other. Let's talk about if we have two sets of data. Each set of data will have its own standard deviation. If there's two standard deviation from these two set of data are significantly different, okay, we use F test. So F test tell you the F value. That means calculate F value. It's S1 squared over S2 squared. And which S is S1, which is S2? We have rule. So always put the larger value as S1. Always let S1 greater than S2. This means F always greater than 1, or at least equal to 1 if 2S is exactly the same. So F at least is 1. So then how can we judge 2S are significantly different or not? So we have a rule. If calculate the F value greater than the table F value. Table F value. Okay, we have a table listed here. Right, this table 4.3 critical value of F. So this is degree of freedom from S1. So we have two sets of data. Each set of data have S. Then pick the one S as a greater value is S1. So that data tell you of the degree of freedom. If let's say if this is the S1 set of data S1, then degree of freedom is this N is 4, right? Minus 1 is degree of freedom. If you have 5 data, then degree of freedom is 4. Then this is S2's degree of freedom. So based on degree of freedom of each set, you can find the S value. If degree of freedom S1 is 4, then you need to take a look at this 4. If degree of freedom S2 is 5, then this is 5, right? So 4, 5, the F value will be 7.39. Okay. This is the F value from the table. Okay. So if we calculate F greater than table F, then these two S have significant difference. Difference between S1 and S2 is significant. While if the calculated F smaller than table F, then S1, S2 have no significant difference. Okay, then next about the confidence interval. In any practical work, we can only deal with finite number result. As I said, we cannot repeat infinity times. Most cases, we repeat 3 times, 4 times, 5 times, maybe 10 times if you have time. But you cannot repeat infinity times. So how can we know the true value? So this is the actual true value, nobody knows. So what we get is the average from our measurement. But English chemist Gossett studied this problem. How can we use our finite number of measurement to predict the true value? And this is statistics. And we will not discuss statistics itself, but just use it in our analytical chemistry. So when he published his paper, he used a name as student. Didn't use his actual name. His actual name is Gossett. So when published his paper, he used a student. So we still call this student's test. Student test. So critical idea is confidence level or confidence interval. Mu equal to x bar plus minus ts over square root of n. This is what we call confidence interval. So for this formula, you realize this actually is a range, right? Plus minus is a range. So this expressing state that the true value, mu is the true value, will lie in a range around this x bar is mean value, right? Around the mean value in some range. This range depends on this t, student's t test. This number. We will take a look at. There is another table based on the confidence level and degree of freedom. This true value is different, and S is standard deviation. N is number you measured. You repeat this measurement. So see, from statistics and Gaussian result here, the true value lies around a range, of mean value for the measured mean value. So here, N is number of measurements. T is a constant for students T value. So as I said, the value depends on confidence level and degree of freedom. Let's see. Yeah. This table is a t value. Depends on confidence level and degree of freedom. Degree of freedom, we just explained, is it depends on how many measurements you made. If you made 3 times, then degree of freedom is 2. If you measure 5 times, then degree of freedom is 4. So always m minus 1. So this column, degree of freedom. And then confidence level we'll explain very soon. Like here, list 50%, 90%, 95, 98, 99, 99.9, or 99.5, lost one, and 99.9. Briefly, what it means, confidence level is how confident you believe the true value lying in this range. 99.9 is the highest confidence. You can not make 100%. This is perfect. In science, no perfect. 99.9% is the highest level. Lowest level here is 50%. Of course, below 50%, this means you're not sure. Below 50%, you're not sure. Is this correct? So at least 50%. So if this is 50%, you find if the degree of freedom is 5, that means you measure 6 times. 6 minus 1 is 5. So 5, degree of freedom 5, 50% confidence level, the t-value is 0.727. If we increase to 90%, then t-value is 2.015. If we want the confidence level is 95%, then t-value is 2.57. Well, you find as we increase the confidence level, t-value is larger. Right. Move to 98%, then 3.365. To 99%, 4.032. Okay. That means since you already measured, so S already there, never change. You already measured 6 times. So S already fixed. No. So S never change. And N, you already measured 6 times, N is 6. Now already change. This means as you increase T, this range will be larger. In other words, this means if you want more confident, you need to give the range is larger. This makes sense. If you larger room, the more confident true value will be in this inside of this range. Okay, let's take a look example. How to use this to calculate confidence interval. If a chemist determines arm in an sample and calculate the average value is 15.30. As standard deviation is 0.10 and he or she repeats 4 times. And just like here, 4 numbers. You can calculate the average, you can calculate the ends. And it's 4. Right. Then, what is a confidence interval at different confidence level? Let's say if this is 90% confidence level, X bar or is there. So you need to find the t value. Then we need to find t value from table 4. What is the t value? 90% confidence level. N is 4. This means degree of freedom is 3. Degree of freedom 3. 90%. 2.353. 2.353. Freedom. Degree of freedom 3. This column. 90% is this column. Okay. We find the t value 2.353. So mu equal to x bar plus minus ts over square root of n. X bar is 15.30 plus minus 2.353 times s is 0.10 over square root of n is 4. Then 15.30 plus minus 0.12. This is the range, right? This is the range actually is 15.3 minus 0.12 up to 15.3 plus 0.12. Actually, range is from 15.18 up to 15.42. This is the range. And if we raise confidence level to 99%, then from the table 4.4, what is the t-value? Use that table. So we find that this time t-value is 5.841. Now the confidence interval will be x bar plus minus ts over square root of n. X bar is 15.30 plus minus t is 5.841 times s is 0.1 divided by square root of 4. This time is 15.30 plus minus 0.29. The actual range is 15.10 up to 15.59. So now, what's the actual meaning of 90% confidence level or 99% confidence level? I explained it briefly, but now in more detail. Suppose for this example, if we run this experiment 100 times, 100 chart, each chart we measure 4 times. So each time we have mean value and a standard deviation. If we repeat this 100 times, at 90% confidence level, this means 90 out of 100 times, your true value will be lying in the range. Okay. Or your confidence level is this range will cover the true value 90 times. Other 10 times is out of true value. If 99% means 99 of 100 times your this range will cover the true value. Only one time not cover the true value. Of course, this is more confident because 99% cover true value. For this example, also tell us if you want to be more confident of the true value be covered by this range, your range will be larger. Right? See this? This is larger range, right? This is smaller range. The larger the range, more confident cover the true value. Of course, larger range, everything covered. And here is another example. Here's confidence level. Let's say, yeah. Another example tell you confidence level. This example is we use computer choose 4 numbers each time. Choose 4 number each time. Randomly choose 4 number each time. And we repeat 100 times. Each time choose 4 number. Then each time you can calculate the average standard deviation and calculate the standard interval, which is a range. Right. And here's this a field square. This range. That means the odd of the true value. True value is 10,000. This line, the solid line is the true value. We'll repeat it 100 times. If you count this, 1, 2, 3, 4, 5, 6, 7, total 100 times. And 50%, this upper level, this is 50%, this is 90%. 50% means half of the range covers the true value, half not cover true value. With field square, this interval or range not cover the true value. You see this is out of true value, right? This. But the open square, the range, like this one, this, all cover the true value. So if we count the open square range and field square range, you find roughly is 50 times. This is 50. This is also about 50. This means 50% of range covers the true value. If 90%, this is 90%. You find this solid is not covered, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Approximately 10. And this open square is 89, approximately 90. So 90% of time your range covers the true value of 10,000. This is another way explaining what it means, confidence level and confidence interval. Hope we can understand that. Again, if we want to be more confident our result cover the true value, we need to give a larger range. And this is very clear, right? 90% of the range is much larger from here to here, from here to here. And 50% of the range is much smaller. Okay. Okay. 6 minutes left. This is 4 about comparison means with students T. we can use t-test to compare one set of measurements with another to decide whether or not they are the same. Of course, we do not expect two sets of data exactly the same, because even if you measure same sample 2 times, you never get exactly the same because of random error. Okay, same means in the random error range, they are approximately the same. We have different cases. So case one, comparing a measured value to a true value. With a true value. Or with a known value. Let's say, example. A core sample certified by National Institute of Standard and Technology, NIST. Obtain result is 3.19. This is the weight or mass percent of sulfur. And you test a new method to see if it can reproduce the known value. Your data or results 3.29, 3.22, 3.30, 3.23%. So you repeat 4 times, you get this data. And for this 4 times measurement, you can easily calculate mean value, right? So mean value is 3.260. You notice that I give actual digit here, right? This is the actual digit. Because we're going to use this for our next work. So that's why we kept 1 more digit. And standard deviation is 0.041. Now the question is, does your result agree with a known value 3.19? Your average is 3.26. Clearly not the same. As I said, you never expect the exactly same. This means reasonable range. So what we can judge is we have 2 methods for this question. Method 1, compute 95%. 95% confidence level. This is most people agree at this level. So we calculated 95% confidence interval to see if this confidence interval covers a known value. Confidence interval is a range, right? This is the idea. If 95% confidence in the interval covers the known value, we call your result no significant difference from the known value. In other words, it's approximately the same. Okay. Then we calculate the confidence interval. First, you need to find the t-value, right? We already calculated x bar and s in n 1, 2, 3, 4, right? So what we need to do is try to find the t-value. Then use the table. From table 4.4, find the t-value. At the 95 confidence level, t. This time, let's see, 95 confidence level, and you need to use confidence. You need the degree of freedom, right? 95 confidence level. Degree of freedom, you repeat 1, 2, 3, 4. So 4 minus 1 is 3. So 1, 2, 3. 95, so 2.776. 2.776. And the degree of freedom, so 4 minus 1 is 3. 95% level. Yes, right? Let's take the 95% degree of freedom. Oh, that point is the wrong place. This is 90. We need a 95. 3.182 at a degree of freedom. 3 is 3.182. Sorry. 3.182. Then the confidence interval we will find in a couple of minutes. Plus minus Ts divided by n square root. So x bar is 3.60 plus minus 3.182 times 0.041 divided by square root of 4 equal to 3.03260 plus minus 0.065. So this means this range will be 3.95 to 3.325%. This range. Is this range covers the known value? No, because this end starts from 3.195, and the known value is just beyond it. Not far, but not included. So the known value 3.19 is not covered, so it's outside the 95% confidence interval. That means our result do not agree with the known value. In other words, our result have significant difference with a known value. But since this value is really close to this end of the range, right? If we measure more measurement and recalculate the average, then recalculate the confidence interval, might be fall into the range. Because this is not far from the end. So this is the case one and one method. We have another method. We'll talk about this next Tuesday.
So do you want us to still go ahead and turn in homework on Tuesday, or do you want to push it back to Thursday?
Just about the chapter 4 homework.
Mm-hmm.
We have chapter more on our mouse.
You said 9:16, didn't you?
Yeah, not next Tuesday.
Let's do 9:16. This homework. Not next Tuesday.
Not next Tuesday.
Okay, so next Tuesday. Oh,
Chapter no, those.
okay.
Not next Tuesday.
Yeah.
We have time.
And then when he gave us today's 2:30.
No, this,
Yeah, that.
This is
this
chapter
is
4.
what's new.
Let's do next Tuesday.
Yeah,
Okay.
not this coming Tuesday, but the next.
Okay.
This is.
Let's do 9:16.
Yes.
Okay.